So now we're going to talk about what happens if we have these complicated fractions that we're multiplying and adding. In number 6, we're going to start with an addition problem. And that's an important note, is that you have to really look and say, what am I being asked to do? Am I being asked to add or subtract? So what if instead of this problem, I said to you, you need to add 3 over 7 plus 5 over 7. You would tell me the answer is 8 over 7, hopefully. Because when you have a common denominator, you can just add the numerators. Well, this problem is very similar to that problem, except my numerator is just a little bit more complicated. I really have 3x over x minus 9, minus. And I'm adding it to 5 over x minus 9. These are its own grouping. Now, a lot of times I want students, or I have students who say, can't I get rid of these? And they want to get rid of those x's. Can't they cancel out? And that's the biggest kind of misconception, is I have students who say, we should be able to get rid of it. Really want to have you understand this idea. When you have something that's a denominator, like this x minus 9, there are implied groupings. And it means when they're being added to each other, those two are connected to each other. It's all or nothing. You have to take the x and the minus 9. You can't take one or the other. So those two are connected to each other. So our answer here would be 3x plus 5, adding the numerators, and we have that common denominator already. This grouping of x minus 9. Now this is as simplified as this problem can be. Nothing else can be reduced. You cannot take the two x's. This numerator, it's its own grouping. The 3x plus 5 are connected together forever, and the x minus 9 are connected together. That has the implied grouping of being either a numerator or a denominator. Okay? Now let's look at, I'm trying to decide 7 or 11. Which one am I going to go to? Let's look at let's go to 11. All right, let's look at 11. So in 11, now we have a very different problem than 6. We have multiplication, not addition. So in the multiplication, what you're going to do is you're going to try to factor first. You have 2 steps, to factor and then see what can reduce. So our first step is, how can we factor? So we have to go back to, we're going to look at just here to begin. We're really going to focus in and just look at this w squared minus 36. And you want to say to yourself, how can I factor this? And you do have to really get good at factoring for this section. Well, that actually factors to w plus 6 and w minus 6. If you remember, it's the difference of 2 squares. You may need to go back and kind of figure out your factoring. One thing I like to do, and you don't have to do this, but I like it, when I see something like 8w, I put it into prime factorization terms. So I say, what 3 numbers or 2 numbers or what prime numbers multiplied together equal to 8? And so I went 2 times 2 times 2 times w. With the 12, I'd go 2 times 2 times 3 times w, and you'll see in a minute why. And the 6 I see just as a grouping. And so I'm just reminding myself I can't just take the w there, it has to be the w minus the 6. Now this is my favorite part, because now you have all multiplication. There's nothing being added here, and that's an important part. There can't have anything added. Everything here is being multiplied. So what you can, if something is the same in the numerator and the denominator, it basically makes a 1. So w minus 6 divided by w minus 6 is 1, so I can get rid of it. I can kind of reduce it out. Same thing with this 2 and a second 2. And this w goes away as well, because there's a w in the numerator and the denominator. My final answer would be w plus 6. We also had the 3 there that was multiplied by it. In the denominator, I have the 2, and that's it. That's my final answer. Okay? So this is my final answer here. This was my final answer here. Now let's look at 7. Okay? In 7, again, a lot of times, almost always, your first instinct should be, can I factor? What can I do to factor it? In 7, I can factor out a 3. Both of those are divisible by a 3. So I'd be left with x minus 8. In the denominator, this one I'd be looking at what multiplies to give me 16 and adds to give me a negative 10. So even sometimes off to the side, I'll be like, what multiplies to give me a 16? And yet when I add it, I get a negative 10. And that's where I'd come with the answer of 8 and 2, if in fact they were both negative, would work. So then I know that in the denominator, to factor my denominator, it's x minus 2, x minus 8. Some people don't need this work over here to the side. Some people do. It kind of is what works for you. So now I am at the step of, can I have the same thing? Do I have a same grouping? Notice how the exact grouping is the same there. So I can reduce it. And then I'm done with 3 over x minus 2. Number 12. Again, my first step should be to factor. What multiplies to give me a negative 21 and adds to give me a negative 4? There's 2, so it's a binomial, so I am dealing with a difference of 2 squares there. I have the square root of the x and the square root of the 49. Next step is, how can I reduce? These go away and this goes away. The x minus 7 is the same in the top. What I'm left with is, I guess I could put it up here on the line, couldn't I? X plus 3 over x plus 7. You don't have to continue to show them as a grouping. It's kind of like this implied grouping that they're in a fraction. All right, and I have an answer here already for 8. I wanted to just kind of show you. 8, I kind of did it a little different. I said, you know what, in 8, I can really just show that I can think of them as 3 separate parts. And so 8's kind of a review of what we did, more in chapter 6 there. 9 or 13 I had to see. 13 was interesting in that we went back to addition. So it went back to addition rules, okay? So in 13 at one point, let's just talk it through here. I had, let's get rid of my 9s for a minute. I had this. I factored out my denominator here, and I said, hey, I can factor out the 9 there. So the denominators are really close to being the exact same. The only thing that was missing is if this had a 9. And so to put a 9, I just have to put a 9 in the numerator and the denominator. So then I had a common denominator, and so I just had to add my numerators together. And so this is me adding the numerators together. Sorry, did not mean to do that. And then now I just want to multiply through. I took 9 times the 2g. I took 9 times the 1. That's how I got this 9. And then I added 12 to it. I got this, and then this one almost done. I had to factor out the 3. And actually, I wasn't even quite done. On a technicality, I should reduce this down. This 3 over 9 can be reduced because now we're dealing with multiplication. And so my final answer should have a 3 on the bottom, g minus h, and on the top, 6g plus 1. You don't need those parentheses, okay? Let's look at 9. 9's about factoring again. So it's going to be factor, 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 and then reduce. So first, what multiplies to give me negative 6 and adds to give me 5? The answer would be plus 6 and d minus 1. 16d, I'm just going to leave it as 16. It's up to you. I could put it as 2, 2, 2, 2d. I think that might be better. 8d plus 16, I can factor out an 8. d plus 2. Sorry, I need a little less space here. Denominator, d minus 7, d plus 6. So it's a lot about factoring. Now, it's about reducing. You can reduce if it's in the same one or if it's in opposite. So let's see, what can I reduce? I can take away the d plus 6. I don't have another d minus 1. These are all separate kind of little groupings here, all right? So I can take away 3 of these. 2 times 2 times 2 does equal 8, so I can take those away. I can't take like this d with this d. This d is part of a grouping. So I think right now I'm done. I've gone as far as I could, and my answer would be d minus 1 times d plus 2. And in the denominator, I have an extra d and a 2 left, and then a d minus 7. I see a lot of students who at this point will multiply it out. Don't. It's extra work you don't need to do. You already took the time to factor it. It doesn't really help you at all to go back into terms of having it multiplied out. So leave it there. This is a great answer right here. Let's look at 14. Numerator, now, I have to really realize something. 14 is different. I'm back to subtraction. I'm no longer doing multiplication. I'm at subtraction. So my first step is still see where I can factor. So here I have this. I can't factor. I have p. I can factor p plus 2, p plus 5. And then I'm subtracting, and I have 2, and I have p plus 2, p minus 2. So in this case, what I'm saying to myself is, what am I missing so that I have a common denominator? All right, so I want to have a common denominator. I want them to both be have the exact same denominator. If only this had p minus 2, and this one had a p plus 5. Now we can't just add things to the denominator, but what you do is you add them to the denominator, sorry, come on, and the numerator. So my new numerator, like if now I have the denominators match. The denominators are exactly the same. So my numerators were p minus 2 times p plus 3 minus 2 times p plus 5. And they're all over this great big denominator of p minus 2. It really doesn't matter the order, p plus 2, p plus 5. Okay? I'm not quite done. I'm really close to being done, but not quite there, because I need to multiply out. I need to see what these are, kind of do what's called the FOIL here, multiplying it out. So p times p is p squared. P times 3 is 3p. Negative 2 times p, negative 2 times 3, negative 2 times p, negative 2 times 5. I'm going to even just do this. I'm not even going to take the time to rewrite those. I know that those are those three groupings. And it continues to equal, I'm going to combine like terms. There's no other p squared terms. I'm going to combine my p terms and it'd be negative p. I'm going to combine my constants, negative 6 and negative 10 is negative 16. And it's all over p minus 2, p plus 2, p plus 5. On a technicality, nope, we're done. I was going to say, can we factor the numerator? And you can't, so we are done. Happily, happily done. Here are 10 and 15 worked out. Just take a minute and look them over and see if you can understand. Go ahead and pause it because the video is going to end.